Alright, we're going to get started with chapter 9. In this chapter, which I will cover in full with this video, simply talks about multiplication, division, and exponents that involve positive and negative numbers. The previous chapter, we went into explaining how to add and subtract positive and negative numbers, which for students usually turns out to be more difficult. I would have to say, in my opinion, multiplying and dividing is a lot more simple in that we can simply apply the double negative rule. Okay, for every two negatives that we see in a product, we can assign a positive and drop the two negatives. Okay, so we start out with a term, product, and a product simply means that two or more things were multiplied together and the result is the product. Okay, there are several ways to represent multiplication. This first one here is not really one of our favorites, since it has a traditional multiplication symbol, and that can be confused with x. Okay, because we're starting to use variables now. The other ones are probably so from here on out, with variables popping up, we can represent multiplication with a dot, parentheses around each variable or number that's a part of the product. We can put parentheses around one of the variables, the second or the first, or in the case of two variables, we can just place them side by side. Okay, as you may or may not know, one way we can express multiplication is simply repeated addition. Okay, so as most everybody knows, 4 times 3 is 12. Okay, another way we could express that is to write 4 3's that are all added together. Okay, so 3 plus 3 plus 3 plus 3 is 12. Okay. The next part reads, to multiply repeatedly add the same value of a certain number of times. Okay, so here we're moving on to a different example. We have a 4 times 3, except now the 3 is negative. Okay, we could use the same reasoning as we did with 4 times 3 and just simply say that we are adding these plus symbols, and we are adding specifically negative 3. So what we do is we simply write out 4 negative 3's. There's 1, 2, 3, and 4. We're adding in the middle, and as we stated in the last section, if we add numbers and they are all the same sign, then we keep that sign. In this case, that would be negative, and we just simply add the absolute values of the numbers, 3 plus 3 plus 3 plus 3, and that gives us our number. So in this case, we'd get negative 12. Okay. Okay. And so depending on what number, and we're referring back to the example of having a negative 3 there, depending on what number we're multiplying the negative 3 by, would determine the number of negative 3's that we actually write out, and we would still be adding. So we'd simply write the addition of negative 3 x number of times if we were presented with the expression x times negative 3. Okay. And this is also with the condition that x is a positive number. Okay. Will this sum be positive or negative? Well, here we are adding as indicated by these plus signs. And then what type of number are we adding? Well, we're simply saying a negative number plus a negative number plus dot 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 plus another negative number. In other words, all of the numbers that we're adding are the same number and they're all negative. So the sum of any number of negative numbers will be negative. So the answer to this question is, of course, negative. Okay, moving along to the next page. All right. We now have replaced the 3 with another variable, and so what we're stating here is simply that we could multiply something by x number of times, and whatever that something is, in this case we have a y, and so with y, the variable being positive, so y could be 1, 2, 3, 4, 5, any number greater than 0, and then if we put a negative in front of it, we pretty much have the same situation as we did on the previous page. We are once again we're taking a negative number and we're just adding it multiple times. Okay, if y is positive and you place a negative in front of it, then you essentially have a negative inside of these parentheses. Okay, with x being positive, we have addition in between, and we write out x number of these negative y's. And so once again, our product will be negative. Okay, and that's what we're actually trying to figure out here. Okay, what's the product going to be? It just happens that we can take the product and write it as a sum. And so if the sum is negative, then we can say that the product of a positive and a negative number will also be negative. Okay. And perhaps I sort of got ahead of myself. That is exactly what we need to put in the blank here. Okay. Since this sum is negative, then our product is also going to be negative. Another way you could look at it is what we're doing here is we're saying that this is x times a negative y, which is a positive number times a negative number. And remember that we want two negatives to make a positive, and so here we only have one, and an odd number of negatives results in a negative product. Okay, an alternate way that you could interpret it. Okay, now we have a note here that simply states, if we were to swap the order of the numbers, Okay, and originally we were discussing the example of 4 times 3, in which we said we can simply write 3 plus 3 plus 3 4 times. Okay, and each one of these 3's was positive. If we calculate this sum, we get 12. Likewise, we can change the order. Okay, we could write 3 times 4, and in this case that means we have 3 4's and we're adding them together, and the sum of 4 plus 4 plus 4 is also 12. Okay, and so if we were to make the 4 negative, then instead of 3 positive 4's, we would write 3 negative 4's with addition operations in between. And so if we add all negative numbers, we get a negative number as the sum, and 4 plus 4 plus 4 is still 12. Okay, so the product of a negative number and a positive is also negative. Doesn't matter whether the positive or the negative number comes first. If we only have one negative in the product, then it will be negative. Okay, so on this page, we consider what if we have 2 negatives. So now both the 4 and the 3 are negative. Okay, and as it's stated here, we can no longer consider the addition of 4 negative 3's. Okay, and so the way we're interpreting this now is we say that we have a negative 3, and that's placed here inside of these parentheses. We still have 4 of them. Okay. But these negatives here that indicate subtraction are the result of the first number in the product being negative, the 4. So we write 4 negative 3's, but now we subtract them. That's where these subtraction symbols come from. Okay, so how do we calculate this? Well, we've broken it down into a subtraction problem, and from the previous section we had decided that we will take a subtraction problem and convert it to an addition problem. In this case, we can use the double negative rule and apply it to each pair of negatives that we see here. Okay, so here are 2 negatives. We'll drop those 2 and replace it with a positive. Here are 2 more negatives. Replace those with a positive. Pick up the 3, and we do that with the remaining pairs of negatives. Double negative rule. And this pair results in our final plus. And so really what we have here are 1, 2, 3, 4 3's added together, and that gives us 12. So what's the sign of our result? It's positive. Okay. And from the beginning, we could have simply reasoned that we have two numbers multiplied, 4 times 3. And with this string of numbers, we could just simply count the negatives. We have 1, 2. For every 2 negatives multiplied, we have 1 positive, the double negative rule. So the result will be positive. Okay, this next part is simply stating that this would be true no matter what numbers you were multiplying. Okay. In this case, we just simply have x and y. Okay, where the variables themselves, x and y, they represent numbers. So x could be 0, 1, 2, 3. Well, actually it couldn't be 0 because we want a number greater than 0. It could be 1, 2, 3, 4, 5, or any number in between. X itself isn't negative, but when we take it over here and insert it in the product, we put a negative in front of it. And so what we're saying is we have the situation of a negative number times a negative number. So this first one we interpret as repeated subtraction. And then the second one we just interpret as the number being subtracted. Yep. Okay, and so in this case we are repeatedly subtracting a negative number. And so no matter how many times we write this out, we are going to have a negative number inside parentheses and a subtraction symbol in front. And so once it's all said and done, we're simply going to have a string of plus y's here. And y could be any positive number. So if we're merely adding a string of positive numbers, we get a positive result. A negative times a negative is a positive number. Okay, you can write positive here to complete the workbook. Okay, 2 negatives multiply to give us positive. Okay, this note at the bottom of 62 pretty much sums up what we do with products, or quotients for that matter, but we'll get to quotients later. If we have a string of numbers that are multiplied, we can just simply count all of the negatives that sit in front of those numbers. Okay, if there's an even number of negatives, 0, 2, 4, 6, 8, 10, then we say the product is going to be positive. If we count the negatives and we get an odd number of negatives, then the product will be negative. Okay, so odd number, negative, and even number, positive. So as always, there's no better way to illustrate a mathematical concept aside from examples. Okay, to see the concepts in practice. So, example 1, all of these numbers are multiplied together. Okay, we simply have a 2 times a 1 times a 4 times a 2. If we multiplied these numbers ignoring the signs, we would get 4 times 2 is 8 times 2 is 16. Okay, but we want to make sure we have the correct sign of the 16. We go back to the original product and we count the negatives, and we see that there are 2 negatives. 2 negatives means that we have a positive result, or you could say a positive product. So this would be plus and that would be plus. For the second part of example 1, we have 5 times 2, which is 10, times 1, still 10, times 4, we would get the number 40. And of course we ignored the signs along the way, but all we have to do now is go back and count the negatives. 3 negatives results in a negative product. So this would be a negative 40. Alright. Example 2, we are looking at fractions now. And so with example 2, we're really just mixing some older math concepts that we saw in the previous chapters with the new concept of even negatives gives a positive product and odd negatives gives a negative product. Okay, we still multiply the fractions together the same way as before. We could write 9 as a fraction if that possibly throws you off. And this negative, if you wanted to, you could pair it with the 4 or the 3. I usually stick the negative with the numerator. You wouldn't want to split it up in both the numerator and the denominator. You would essentially be adding a negative into the problem, which would change the problem. Okay, so you either want to put it on the top or the bottom. And now with fractions, as before, we simply multiply the bottom times the bottom, the top number times the top. 9 times the 4 is a 36 on top. 1 times 3, 3 on the bottom. And now we count our negatives, and we only had 1, which is odd, so that would be a negative 36. And then 3 actually goes into 36 an even number of times. 3 divided by 3 is 1. 3 divided into 6, 2. So for this result we get a negative 12. And it makes sense if you go back to the original product. We simply have a 9, which is positive, times a fraction, which is negative. And so we only have in this product one negative. And so in the end, you should expect a negative product. Alright, B. I will associate this negative with the numerator, negative 1, and then I'll write 7. And on the bottom, I have a 2 and a 5, and I'm multiplying these fractions. So bottom times the bottom, 2 times 5, we would get a 10, and then the 1 was paired with the negative, and so this is a 1 times 7 on top, and I count one negative with this pair of numbers on top that are multiplied, and so that would result in a negative 7. Overall, I get a negative 7/10. And again, if you simply go back to the original problem, we have a negative 1/2 times a 7/5, and you only count one negative in here, so you should expect a negative result. One negative. So we get a negative result. One negative. And so we see down here that the 12 was negative. Example 3. In this case, we just simply have more numbers that we're multiplying together. Now we have 1, 2, 3 numbers. Okay, we have a negative number, negative 4, times a positive number, 6 over 7, times a negative number. In this string of 3 numbers, we have 1, 2 negatives, and so we would expect our product to be positive. Even number of negatives. What about B? And we'll go back and we'll still multiply the numbers, of course. But 3 over negative 8, we would look at 3 over negative 8 as a negative number. 3 is positive. And here we actually have 2 negatives in one fraction. Okay, so if we apply the double negative rule to the negative on top and bottom, we have a pair between them, and so we would call that positive. Okay, the way I've written out the signs for the 3 numbers, I have 1 negative, and so I would expect my product to be negative. Or if you wanted to, you could simply look at the original problem, and you would probably count 1, 2, 3 signs, 3 negatives, which is still odd. And so you should expect a negative product. Okay, so let's actually go back and multiply them now. Hopefully you've gotten plenty of practice multiplying fractions from the previous chapters, so it shouldn't be too much of a task. We can write 4 as a 4 over 1, and then we have dot for multiplication, 6 over 7 times 5 over 3. We've already worked out that it's going to be positive, and so at this point I simply multiply all the numbers together on the top. 4 times 6 times 5. The 1 is not going to affect the product on the bottom. We could just simply write 7 times 3. Okay, 6 times 5 is 30, times 4 would be 120 on the top, and then a 7 times 3 on the bottom would give us a 21. Okay, 120 over 21, of course, can be simplified. We just simply divide both the top and the bottom by a 3, which gives me a 7 on the bottom and then a 40 on the top. Okay, and again, we've already worked out the sign of the product. We counted 1, 2 negatives in the beginning, and so this would be a positive 40 over 7. What about B? Okay, so we know the tops are all going to multiply, and the 3 is a numerator, so the numerator of our product would be 3 times 3, and then times a negative 2. And then for the denominator, we have negative 8 times 1. In that I could write the 3 in the middle as a 3 over 1. So negative 8 times 1, and then times a negative 7. Okay, but once again, we've already worked out the sign. I know it's going to be negative because I count 1, 2, 3 negatives. That's an odd number of negatives. And then on the top I have 3 times 3 is 9, times 2 is 18. And 8 times 7 on the bottom is 56. Okay. At the moment I can only think of 2 as a common divisor for the numerator and denominator. And so 18 divided by 2 is 9, and I keep the negative with the numerator, and 56 divided by 2 is 28. And 9 over 28 cannot be reduced any further. Okay, so 3 over negative 8 times 3 times the negative 2 over negative 7 gives us the product negative 9 over 28. Now, what about dividing integers? Well, it works out, it's just as simple as multiplying. If all of the numbers are involved in the quotient, then we simply count the number of negatives, and that determines what the quotient, or determines the sign of the quotient. Okay, and then we just go about dividing the numbers in the usual way. Okay, and we have three results that can be confused a lot of times, and that would be dividing with a 0 involved. Okay, and the quotient isn't always 0 when 0 is involved. So let's talk about the results of these three situations, and then try to come up with a reason why it is that way. Okay. If we look at this explanation in regards to dividing, what we're doing is we're taking a division problem. Okay, we've taken some number A divided by B and gotten C. Okay, what we can do is take this division problem and rewrite it as a multiplication problem. Okay, and it's a lot easier to see what I'm talking about if I were to use some numbers. So let's say I have 6 divided by 3 equals 2. Okay, why is 6 divided by 3 equal to 2? Well, it's real simple. 3 times 2 equals 6. So I can take a division problem and rephrase it as a multiplication problem. So if we follow that reasoning for 0 divided by 8, okay, and I want to know the product, but I don't know what number I'm actually supposed to get by dividing 0 by 8. Okay, it may help to translate it into a multiplication problem. So what did I do up here with the 6 divided by 3 equal 2? Well, I took the denominator of the fraction, the division, and I multiplied it by the right side of the equation. So in other words, I would get an 8 times some number equals 0. Well, there's actually only one number that I can multiply by 8 to get 0. And that number is 0 itself. So, 0 divided by any non-zero number is 0. Okay. Written in a more general way, if I have 0 in any number x, then this will calculate to be 0. Okay, so the second situation that we can run into is 8 over 0. Well, what number does that equal? We'll use the same reasoning for this question, and we'll say, well, let's rephrase it as a multiplication problem. 0 times the number equals 8. Okay, you can try to think of a number, but you will not find one. 0 times 1, 0. 0 times 0, 0. Uh, 0 times a negative number, negative 5, 0. No matter what you place in substitution for this number, you get 0 and not 8. There is no number that's defined such that we multiply by 0 and get a non-zero number, whether it's 8 or 1 or 10. If we multiply by 0, we always get 0. So this number is undefined. Any non-zero number divided by 0 is undefined. So x divided by 0, where x is a non-zero number, UND, undefined. Okay, and that leads us to our last situation involving 0 and division. Okay, what is 0 divided by 0? We'll rewrite this as a multiplication problem. 0 times some number equals 0. Well, we just listed a few up here. We listed several of them. Okay, we could write more. I could use any number. Let's say pi. 0 times pi, this irrational number, equals 0. 0 times 0 again equals 0. 0 times a fraction, 1/2, equals 0. Okay, and so we are actually getting the result that we want, which is different from this second situation where we couldn't get 8 no matter what. But here, no matter what we plug in for the number, the pound symbol, I'll get 0 anyway. And so we really can't pinpoint what that number is. And so we simply say this number is indeterminate. We can't determine which number that is. It could be any of these numbers. So to finish that page, 0 divided by 0 is indeterminate. Okay. And this would be the same thing. 0 divided by 0 is indeterminate. Okay. Now this walks through a little explanation of dividing and how we mix the signs of the numbers. Okay, there's when two numbers are divided, okay, a couple combinations. You could have a negative divided by a positive, or you could have a positive divided by a negative, a negative divided by a negative, or a positive divided by a positive, which is probably the one you definitely already know. But the same rules apply to division as multiplication. We simply just count the negatives. Okay, So the quotient of two negatives, 2 being an even number of negatives, you should expect a positive quotient. Okay. And then the quotient of a negative number and a positive, well, there's only one negative. One negative is an odd number of negatives. So this quotient would be negative. Okay. So what we have here is 35 divided by 5. If we ignore the signs, 35 divided by 5 is 7. Now if we go back to the original problem and just simply count the negatives, we only had 1. And so that should be a negative 7. Okay. Negative 6 times a negative 9, well, we're back to multiplication. 1, 2 negatives, that's an even number, and so this would be a positive product, and 6 times 9 is 54. Negative 3 times 7 would result in a negative number because I only count one negative, and I'd get a 21. 3 times 7 is 21. For D, 18 divided by 2, ignoring the signs, I would get a 9. If I count the signs now, I have 1, 2 involved in this quotient. 2 is an even number, so this should be a positive 9. Okay, section 3, exponents and the order of operations. PEMDAS, please excuse my dear Aunt Sally. Okay, how do negative numbers and exponents and parentheses play together? Okay, well, what you need to notice in example 5 is that we have a pair of parentheses here with an exponent immediately on the outside to the right. What this means is that we take all of everything on the inside of the parentheses and write it twice. Okay, essentially multiplying that times itself. And so since we have a negative 5 here and it's squared and both the negative and the 5 are on the inside of the parentheses, we write a negative 5 twice. So we have a 5 times 5. Both of these numbers are multiplied. 5 times 5 is 25, and we apply the double negative rule, and so we get a plus 25, which is what's supposed to go in the box. So when the exponent is immediately on the outside of the parentheses, that exponent applies to everything inside the parentheses, including the sign. So negative 3 to the, or negative 2 to the third power would be 3 negative 2's multiplied together. 2 times 2 times 2 is 8, and now we count the negatives. There's 1, 2, 3, and 3 is an odd number, so 8 should be negative. Okay, example 6, we have a negative 8 squared. That means that we write negative 8 twice, and we multiply the two together. Writing it that way, we now have two negatives, and so that would be a positive product, and 8 times 8 is 64. And here we see the difference that the parentheses make. Notice that the negative and 6 are no longer grouped inside of parentheses. when written this way, the exponent 2 only applies to the 6 and not the negative. So we write 2 6's, but we only carry the negative along. Okay. Still only having one negative. 6 times 6 is 36. 1 is a negative number of, or 1 is an odd number of negatives, so we get a negative 36. We get a negative product. Example 7, exponents and signed fractions. Okay. So what do we do here? We have two boxes, so I'm just assuming that perhaps we work with one piece at a time. I will carry the negative over to the top, and then on the bottom of the fraction we can simply just write 2 times 2. Just looking at the numbers, we have a 5 over a 4. We only had one negative, so it just kind of rides along with it. Okay, so we get a negative 5 over 4. Okay, what about this expression? Everything is inside parentheses now. The negative, the 5, the 4, and the exponent tells me that I have 3 negative 5 over 4s, and they're multiplied. So I no longer need this exponent 3 if I write this negative 5 over 4 out 3 times. Okay, so now I can simply write this product as on the bottom 4 times 4 times 4, and then on the top I have 5 times negative 5 times negative 5. There's 3 negatives there, so that's an odd number of negatives. I know I'm going to get a negative product in the end. 5 times itself 3 times is 125, and 4 times 4 times 4 would give us a 64. And we can't simplify that. There's no common divisors. Okay. And so what we could have said is that we have one negative inside the parentheses, and then with the exponent, that tells us how many of those negatives we have. 3 negatives multiplied times each other. So if we have a negative with an exponent or an of 3 or any other odd number like 5 or 7, then that means we have an odd number of negatives and the product is going to be negative. Okay, and that only applies to the negative inside combined with the exponent. If we have additional negatives on the outside, then the outcome could change. Okay, so how does the order of operations and our rules for positive and negative numbers play together? Okay, so that takes us to example 8. Alright, we have two operations here, addition and division. And whenever we're considering a number involved with a certain operation, we want to consider the sign in front of it as well. So what we have going on here in the second part is a negative 24 divided by a negative 6. And we could actually include this plus here, even though it's not going to make a difference. We could consider all of these signs. Okay, so if we just calculate this part, a 24 divided by 6 is a 4. Now if we count the signs associated with these numbers, we have 1, 2, and so that makes a positive 4. Now, this positive was addition. So depending on these signs, I definitely want to replace this box, this part that I calculated, with an addition symbol or a subtraction symbol when I do replace it. So when I carry over to the side with my negative 12 and I replace the 24 divided by 6, I want to make sure that I put this plus along with it to indicate that I'm adding the 4. Okay, we're now adding numbers with opposite signs, and so we say 12 minus 4 to give us an 8. We subtract, but then I take the sign of the number with the larger absolute value, and so this 8 should be negative. Okay, example 9, more practice. Alright, but now we have to pay attention to our signs. And so with the order of operations, PEMDAS, we are concerned with parentheses first, and we have some parentheses here, and then we have some more parentheses over there. This first set, we could actually say that we have a division problem inside. 4 divided by 2, and 4 is negative. And then over here inside these parentheses, we have a negative 2 subtract 3. Okay. So what I'll do is I'll simply calculate these parts and plug them back into the expression. Negative 4 divided by 2. 4 divided by 2 is 2. And I only have one negative associated with that quotient, so that would be a negative 2. What about this difference? And I'm only looking inside the parentheses. Well, I can rewrite negative 2 minus 3 as a plus minus 3, so that I see I'm simply adding two numbers with the same sign. So a negative plus a negative will be a negative. 2 plus 3, add the absolute values, I get a 5, and so that should be a negative 5. Now, so inside that set of parentheses, okay, and I want to carry down everything that I didn't use. I have a negative, this one here. Then I still have my parentheses. I just carried out the calculation inside, the quotient, and so I put a negative 2 in there now. I didn't apply this exponent, so I want to bring it to the next step. I've calculated the inside of this set of parentheses, and I got a negative 5. And I didn't apply that exponent, so I need to bring it along with the negative 5. And now a lot of students are tempted here to apply the double negative rule to these two negatives, but you have to remember that the order of operations takes precedent over multiplication. When you apply the double negative rule, what you're doing is you're doing multiplication before the exponents. Okay, and that's not what you want to do. So if you want to write this out without the exponent, then you would need to write 3 negative 2's multiplied together like this. And then likewise you could expand this exponent as a negative 5 times a negative 5, 2 negative 5's multiplied. Okay, and so with this product, okay, and this whole expression is definitely not one big product, because if you see here we have parentheses plus and then another set of parentheses, so we have a plus sign in between with no numbers. So this is definitely addition, and so we have a product here. We'll count the negatives associated with it. 1, 2, 3, 4. That's an even number. So I'm going to end up with a plus number. And to calculate that number, we multiply 2 times 2 times 2. And so we see that we get 8. I like addition versus subtraction, so I'll just simply bring this addition symbol over behind the 8. And then I will consider the 5 times 5 with the 2 negatives. And here again I apply the double negative rule. 2 negatives multiplied gives me a positive number, so this should be a plus 25. And there's no negatives anymore, not even subtraction, so 8 plus 25, we get 33. So the key to these types of problems is taking your time and trying not to do too much in one step. Okay, what about this second expression over here? Well, we have parentheses, the negative 1 plus 4. We have exponents. Okay. We have subtraction, addition on top. And then we have a large fraction bar which indicates division. But remember, with the large fraction bar, that pretty much means that we carry out that division as the final step once the top and the bottom have been worked down to a single number each. Okay. So I'll write my large fraction bar. I'm not going to mess with the addition first. It's way down here on the bottom of the list. And then the first thing on my list is the P for parentheses, and so I want to complete this calculation inside the parentheses here. Negative 1 plus 4 gives me a 3. Okay. And now on the bottom I have a negative 2 subtract. Alright. I don't want to combine these two negatives. Again, this negative has a 2 that needs to be applied to it first, an exponent of 2. If you want to, you can get rid of that exponent by simply writing out 2 negative 2's on the bottom and writing them in a way such that they're multiplied. Okay. So once again, big fraction bar. We won't take care of that until the end. On the top I have a 3, and then on the top I have an exponent, 3 squared, and so that would be a 9. And now on the bottom, if I consider the subtraction symbol along with the product of the 2 negative 2's, then I can simply call this a negative 2. I have 1, 2, 3 negatives. And I got my number wrong. 2 times 2 is of course 4. And so whenever you include addition or subtraction, you want to replace that with a sign to indicate either subtraction or addition. Okay, so I included that subtraction symbol, so I go over here to the right, and beside the 2 I write minus 4. On the top I have a 3 plus 9, which is a 12. On the bottom, I could rewrite it as -2 plus a -4, and so I'm adding like sign numbers on the bottom. A negative plus a negative would result in a -6. 12 divided by 6 is a 2, and associated with these two numbers, I only have one negative, and so that would give me a quotient of -2. Okay, so we've reached our last example of this chapter, example 10, and we've mixed in some absolute value bars. And remember that absolute value bars are not grouping symbols, in the sense that if we were to have a minus minus, much like the minus minus here, and instead of bars we had parentheses, and again with these parentheses there's no exponent here, you could consider the exponent to be 1, but that doesn't prevent us from applying the double negative rule. The 1 for an exponent is okay. So this negative and that negative can be combined to give us a +1. That does not work the same way with these absolute value bars. Isolating this piece alone, okay, a negative absolute value of -1, we would not apply the double negative rule. We would simply take this negative, and perhaps it would help if I put it in a different color. This red negative here would simply just tag along. I'd move it over to the right, and I would only consider or calculate in this step what is the absolute value of a -1. Well, it simply, absolute value simply takes a negative number from the inside and outputs the positive version. Okay, so this negative was sort of waiting on whatever number came out of that absolute value. And so the result here is a -1. Okay, and obviously different than the result that involved parentheses. So again, absolute values are different from grouping symbols. And so now I could go over here and rewrite this expression as absolute value 10 minus 12 absolute value bar, and then negative absolute value of -1. I've calculated that. That is just simply a -1. Okay. We have an operation inside of the absolute value bars, and so we'll just simply carry that out. A 10 plus or a -12, 10 minus 12 is the same thing as 10 plus a -12. Okay. And so my 10 and my 12 are opposite signs, so I actually just take the numbers and subtract them. And so inside the bars, I haven't applied those absolute value bars yet. I have a 2, and between the 10 and the -12, -12 has the higher absolute value, and so I go with the sign it had originally. So 10 plus a -12 is -2. Okay, how far is -2 from 0? Well, that's 2, and now I can drop the bars, and this subtract 1 is waiting for it on the outside. And so in the end, this all boils down to a 2 subtract 1, which is 1. So I hope I worked everything out with all the steps, and definitely hope I didn't make any mistakes. Feel free to let me know, either in class, or of course you can always send me an email, and here's my email address. If I made a mistake, I definitely appreciate it if you tell me which video, which chapter, and which example I may have made a mistake on. Or perhaps I worked an example and maybe you'd like to see an additional one. Or maybe the way I worked it out was unclear. Feel free to stop by my office. I am in Office C23 of the Science Center. Okay, thank you. I hope you enjoyed the video.